Right.
All right. We're doing exercise 7, which is a parallel circuit lab. And we're going to need 3 resistors, which we have out ready to go. And we're going to need an amp meter. So the first thing we're going to do is hook up an amp meter to our gear. So we're going to disconnect the power from the positive side, hook it up to the amp meter, and then bring the other side of the amp meter back and hook it up to the plus on the proto board. So now we have an amp meter hooked up. And we're going to need 2 resistors in parallel, a 2.2 and a 3.3K resistor. Now on a proto board, all the 5 poles that are in a column are hooked together, and they're not hooked to anything else until you hook them up to something else. So that's why we're putting these 2 resistors in the way we are. And then we'll bring power into one side, and we'll hook up the negative side to the other side. And now we are ready to turn on the power and turn on our amp meter. So our amp meter's on, we're in amps, we're in 20 milliamps, and we have power. And is that close enough to 10 volts for you? Oh my goodness, we're at 10 volts. So we're at 10 volts, and we see the total current, 7.56 milliamps. So we record that in table 7.3. We now need the voltage source, and it dropped to 9.9 volts, so we'll allow that to be. And now we're going to measure the voltage across the resistors. And we expect to see something close to 10, and we see 9.94, which is pretty close to 10. And we look the other way, we get 9.93, and there's no reason for them to be different, but that isn't different. That's the same. Okay, good enough. And then we're supposed to calculate the total resistance. And I didn't bring my calculator, but if I go 10 volts and I divide it by the 7.56 milliamps that I have, I'm going to get a total resistance that's around 1.32 kilo ohms. Okay? And then we get to table 7-4, we get to calculate the power. So we do voltage times current for total power, and then we do a power and resistor 1, power resistor 2, and then we add them together, and they should be the same as the total. All right. Next, we're going to go and connect another resistor, a 4.7K resistor in parallel with the first 2. Before we do that, we're going to turn off the power. And now we're going to add another resistor to the mix. Okay, now we have 3 resistors in parallel. Okay, we're going to turn the power back on. Before we do that, we'll ask the question, is the total current going to go up or going to go down? I just added a 4.7K resistor. And that's going to mean the total current will go down, get smaller, and the total resistance will get smaller because I added more resistance in parallel. So that means the current should go up. So we turn on and we see that we used to have 7.5 milliamps. Now we have 9.58 milliamps. So the current did in fact go up. And our voltage dropped a little bit, so we're going to increase our voltage just a little bit to try to get back up to 10. going the wrong way, so that's helpful. Okay, so now we're back up to 10 volts, and we see 9.74, 7.578 milliamps. Okay, and we record that in table 7-5. We also have to calculate the total current. It's called total resistance in step 6, and we've done that too. We get about 1K. Okay, now we're supposed to record the voltage of the source. I see 10 volts on the voltage to the source. And now we're going to measure the voltage across each of the resistors one at a time. And we should see something close to 10. So I see a 9.93, and I see a 9.96, and I see a 9.99. Oh, that's a 10. Okay. And those were taken in reverse order. So resistor 3 was measured first, and resistor 1 was measured last. And then we're going to calculate the total resistance given those numbers, and we get the same 1K. Okay, turn the page. We're now going to go and do it over again, but this time we're going to calculate powers, so there's not a problem with that. And now we're going to do it one more time, and this time we're going to use 1K resistors. Okay, so we're going to use 3 1K resistors in parallel. And if we do the math on the total resistance, we should be around 333 ohms. But I spent a lot of money on these resistors, so that means that they aren't really 1K. They're 1K plus or minus 10%. So now we have 3 resistors in parallel, 1K each. We're going to have to change our amp meter so that it doesn't go out of spec. And we're going to decrease the voltage just a little bit. So we're back to 10 volts, and we have 30.2 milliamps. And we take 10 volts and divide it by 30.2, and we get 333 ohms or thereabouts. And with that, we are done doing everything except the problems in the simulation for experiment 7.